Okay, so one more method. This is going to be a shorter video. This is a fairly fast section. This is actually section 8.2, and that is Improved Euler. And so the idea here, the reason I'm bringing this up now is because it kind of looks at the differential equation solver in a little bit different way. So suppose that we have phi of t is our actual solution to the differential equation, so that phi prime of t, by the way, I'm thinking of y is a numerical approximation to our solution. So then phi prime we're thinking of as being f of, this is just to match the book's notation, by the way, f of t, phi of t. Okay. Then intuitively, because this is phi prime, right, you could just integrate both sides from time tn to time tn plus 1. And what would we get? Well, on this side of the equation, we get phi of tn plus 1 minus phi of tn. Okay, and then on this side, we get the integral from t sub n to tn plus 1 f of t phi of t dt. Good. So therefore, we get the formula that phi of tn plus 1 we could just write as phi of tn plus the integral tn plus 1 f of t phi of t dt. Okay, good. Now, of course, the problem with this right hand side is that phi of t is the unknown here, right? That's why we can't just do this in general. Okay, so but I think this formulation of the problem really gets at the heart of things, because our methods, our solving methods, we use are approximating this quantity. Right, and so one way to approximate that quantity is to just use our Euler's method. So our Euler was just to do the integral from t sub n to tn plus 1 of f of t phi of t dt is approximately equal to h times f of tn yn. Right? And so in this case, all the information, the approximation is happening. The approximation is all happening at time tn, which is the left side of the left side of the integral. Okay. Similarly, if we think of the improved Euler, right? The improved Euler, or sorry, backwards Euler, I should say. We're taking tn to tn plus 1 of f of t phi of t dt, and we're approximating that by h of f of tn plus 1 yn plus 1. And now this is all happening at t equals tn plus 1, right? So that's the right side only. Okay, so the improved Euler comes in and it says, well, how about if I don't use one or the other? How about if I use the average of the two? And so the improved Euler is going to be using this approximation we're going to take h times the average, f of tn yn plus f of tn plus 1 yn plus 1 divided by 2. And of course, we run into that issue right off the bat again, right? That we don't know how to compute that because the yn plus 1 is sitting over here. Right, so that, what did we call that? That was an implicit method before. And so what we typically would do then is we would approximate that by our final formula here, h times f of tn yn plus f of tn plus 1, but then instead place of yn plus 1, we're going to do what? The ever popular Euler, regular Euler. Do I have everything there? Divided by 2. Okay, and so how are we going to put that into MATLAB or Octave? So when we come into our loop for I equals 1 to n minus 1, we already have our function f defined. So what we can do is we can say k1 is equal to f of tn yn. Then we can say k2 is equal to f of tn. Now remember, kn is the evaluation here, right? So therefore we can ask, oops, I need the advanced time. Now it depends on whether I know all the time values or not. If I don't know all the time values, I can just add h here, right, to get tn plus 1. Typically we would know, and so we would just put tn plus 1 there. We'll see that difference later. And so then we would have our yn plus k2 times h, or h times k1, sorry. Good. So that's tn plus h, and then this is yn plus h times k1. Good. And then finally, we get our yn plus 1. And that's going to be equal to, oh, I'm changing notation on you all of a sudden. Y is the same thing as y of n here. Okay. Yn plus 1 is equal to y of n plus h over 2 times k1 plus k2. Good. Okay. By the way, this is similar to the trapezoidal rule for the integral. And so this would be our improved Euler end. Good. All right, so I'm going to have some code on our class website that you can use. Some of it I'm going to want you to actually do some modifications to. Okay, so I'll put the forward Euler up for sure, and then see if you can modify the improved Euler or the regular Euler to get backwards and improved Euler. Okay, I'll talk to you later.